Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of try, that is nothing but maximum XOR of two numbers in an array. So without wasting time, let's move on to the question and let's try to understand it. Okay, so in this question, if I talk about the input, we are provided with an array or an array list, or we can say the vector. Okay, vector of some integer value. Okay, so here I'm taking as 2, 8, 2 and 10, 8, 2 and 10. And what we need to find from this values are, we just need to find a pair of the integer values uh, whose XOR value is actually the maximum. So there may be possibility you are not getting the problem statement. So let's try to break it out and let's try to understand it. Okay, so the first thing is that we need to find the unique pairs from this unique unique pair from this vector, that is 8, 8. This is one of the unique pair. Similarly, this 8 and 2, this is the unique pair. 8 and 10 unique pair. 2 and 2 unique pair. 2, 10, and at last 10 and 10. This is also the unique pair. Now let's discuss the XOR values of 8 and 8, that is 0. Similarly, XOR of 10 and 10, this is 0. 10 and 10. 8 and 2, 8 and 2 is nothing but 10. 8 and 10, what is the XOR of 8 and 10? That is 2. 2 and 2, 0, and 2 and 10, 2 and 10 is nothing but 8. So these are the XOR values of each and every pair. Now what we need to do in this question is that we just need to print the maximum XOR value of any of the pair of the unique values. Okay, now the first thing is that you might be thinking that why I have not included 2 and 8 as one of my pair. Similarly, why I have not included 10 and 2 as one of my pair? Just because these values get repeated. Okay, if I perform the XOR operation, then the XOR between 10 and 2 and 2 and 10 are actually the same. So that's why we are not considering those values. Okay, now what we need to print is let's discuss the print. Okay, so output format, that is we just need to print a single integer value, that is nothing but this maximum XOR value. So this is the problem statement. Let's try to understand one more thing, one more test case, that is nothing but I'm considering here the values, that is the 3, 5, 25 and 2 and 8. So what we need to do in this question also is that we just need to find a pair whose XOR value is actually the maximum among all the other pairs XOR value, that is 2 and 25. So when I perform that XOR operation between 5 and 25, the value which I get is 28, and this value is actually the maximum value from all the other pairs XOR. Okay, from all the other pairs XOR. Now you might be thinking that why this is the maximum value, there definitely be other XOR pair whose XOR value can be maximum. Then I will say that no, the XOR value of both of these values are maximum among all the other pairs. So this is the problem statement. Now it's my humble request that you please pause this video right now and then try to solve this question by yourself, and after that was the solution part. So I am assuming that you have tried by yourself. Now let's try to figure out the solution approach. The first new approach of solving this question, that is using the two nested loop. Okay, and definitely this idea might come to your mind. Okay, and even you have tried this idea. Okay, so what you have done, you have used the first loop for the iteration and similarly the second loop for the iteration, and each time you are going to select a pair and then calculate the XOR between both of these values. Okay, and you are going to store it in some other variable that I'm assuming it as a max, and each time updating the max value with the maximum XOR value. This idea is perfect for the small test case. It works fine. Okay, it works fine, but the question that we are discussing right now is actually a try question, and when you going to solve when you go and try to solve this question by the approach that I discussed right now, that is the nested loop approach, then this then all your test cases will not pass. Why? Just because particularly in this question, it is expected that you only try to solve this question by a try concept. Okay, and not by the nested loop concept. That's why the input test cases are very big. When you go and try to use a nested loop on those values, there will be a time limit exceeded error on your screen. So let's discuss the another approach of solving this question, which I'm already saying, that is the try approach. Okay, so before moving on to the try approach, before directly moving on to the intuition of this question, what we are going to do, we are just going uh, to understand this concept a step by step. So the first step is understanding the XOR. Okay, like here we are saying that we are trying to find the maximum value among the XOR value. So let the first thing is how the XOR works. Let's try to understand it. Okay, we know that we have already studied the XOR in the digital electronic subject, and it is nothing but a gate, and it has some features. Okay, some features in a way that it gets some input and it shows some output, and the output will depend on that particular input format. Okay, that is 0 1 0. Similarly, I'm not assuming actually, the property of this XOR says that when I get both the value as low as an input, that is 0 and 0, then I'll keep the low value. Similarly, if I get both the values as high, that is 1 and 1 as an input, then I show plus sorry 0 as a, that is the low value as an output. So the property of XOR says that if both the values are low and if both the values are high, then I show the low value, that is the 0. But if one of the value is high and one of the value is low, then I print 1 and 1. So we already know this. Okay, this is not as much important, but the important part is that understanding how this concept actually help us to get the maximum value. How this help actually, this concept actually helps us to get the maximum XOR value. Okay, maximum XOR value. So let's try to understand what is the maximum value. So we know that the we already know that the integer value in annual, like I am assuming the integer value is of 4 byte, and most of the compiler declare 4 byte and a byte of memory for the integer value. It is not a new thing. Okay, so what the 4 byte has, 4 byte has 32 bits. Okay, now what if I say that what is the 32-bit maximum number, then you will say that I'll do nothing, I'll just put 1 among all these 32 bits. You will say that I just put 1 among all those 32 bits, and the number which I get is nothing but the maximum number of the 32-bit number. It is just same as I'm asking for the 3-digit maximum number, then you will say that I just write 39 and this will be the maximum 3-digit maximum number. Now you might be thinking that why we are putting here the 1, just because when we start talking about the bit, generally we start dealing with the binary data. Okay, and the binary data only consists 0 or 1. Okay, and just to show the maximum value, I have written here the 1. Okay, so you know that the maximum value is nothing but whatever be the number of bits we are provided, we just put 1 into all those bits and we just get the maximum value. Now let's try to understand with another example. The whatever we have done till now, like whatever the problem discussion we have done till now, what we are going to do, we are just going to try to solve it in a little deeper concept. Okay, so what I'm going to do here, I'm just going to write some binary data. Okay, we already know that the input format is nothing but a decimal number. When we perform the XOR operation, definitely XOR operation performs it in the binary like performs the XOR operation in the binary format. But now what we are going to do is that for the better understanding of this question, we are just going to dry run this problem into the binary data. Okay, so I'm just going to write here some of the random binary digits. So assuming 0 0 0 1 0, this is one of the binary number. The second binary number is 0 1 1 2 3 0, and third number is 1 1 2 3, this third number, and 1 0 0 1 0, this is the fourth number. Similarly 1 0 1 0 0, this is the fifth number, and this is also one of the numbers 0 0 1 0 1. This is also one of the binary digit number. Actually if I talk about the input, then within the input you get the decimal number only. But for the better understanding, okay, for the approach of the try, what we are going to do, we are just assuming that as an input we get the binary digit, and we only need to work on the binary number. So I'm assuming what according to the question, if I use the nested loop approach, what I'll do, like I am finding the maximum XOR. Obviously the question is that what I'll do, I'll pick that number, I'll find the XOR with all the other numbers and find the maximum XOR, and I just update in some of the variables. Similarly, then I choose this number and then I will perform XOR then the remaining number, accepting this. Okay, accept this number, I choose this number and perform XOR with all these numbers. Similarly, I update the max with the previous XOR and the new XOR. Similarly, I did this for I do this, I do the same for this number also, do the same for this number also, similarly for this and this also. Okay, I hope you get that what was our approach which we were earlier, which we were doing earlier. Okay, but now what will be my approach is that what I'm going to do is that I'm going to find the number. This time I'm going to find the pair from all of these numbers. I'm going to find the pair among all these numbers. So let's choose this number. Okay, I have choose this 0 0 1 0 1. You already know that to find the XOR of two numbers, we have to select the two pairs, but here I have selected this one. Now I'm not going to perform the XOR with the remaining numbers. This time what I'm going to do, I'm going to actually find that number, uh, particularly that number whose XOR with that number actually the maximum value among all the other values. Okay, so how will I find? I'm assuming that that number is nothing but the X. Okay, so here I'm writing it at X. So according to my concept, what I'll do, my faith is that when I perform XOR between this X and this number, when I perform XOR between both of these, I will get nothing but a maximum number. This is my faith, and I'll solve this question with the same faith. Okay, and what was my faith? My faith is that the number is X, and the moment I perform XOR between that number X and this number is X is nothing but selected from among all these values. Okay, definitely we will try to figure out how we will try to find this number X from these numbers, but right now I am assuming that I have selected a random number X from the remaining numbers, and when I perform this XOR between this X and the first selected number, I'll get nothing but a maximum number, the 5-digit maximum bit number. So what is the 5-bit maximum number? That is nothing but 5 times 1. We already know that why it is maximum. Okay, so this is the maximum number. Now according to our XOR concept, what the XOR says, just that if you want to get the 1 as an output, there may be two input, that is one low and one high. Okay, so as there is 0 that is mentioned here, that means definitely in the other number there should be 1. Okay, otherwise I can't get here 1 as an output. Okay, so here you can see that I'm assuming like I'm taking a back step. Okay, I'm taking a reverse approach of finding the number X. Here I have hypothetically imagined that for this particular number 100101, I'm assuming that I am trying to find out a number X from the remaining numbers when I perform the XOR between that newly finded value and the old selected value. When I perform XOR between both of these value, I get nothing but a maximum 5-digit bit number, and that 5-bit number is nothing but 11111. Similarly, now what I'm going to do is that taking the reverse approach, now I'm finding that X, that is the value which I have selected from the remaining values. So as I know that here I have chosen the 1, as here I have chosen means here just to get the 1 here in the X, the 1 need to be present. Okay, it need to be present. Similarly, moving forward, here the 0 is present. Okay, so the moment I come to know that 1 need to be present here, then here we can figure it out that how many numbers in our all the numbers are there which can be the active candidate to be that number X. So here I come to know that these 1 2 3, actually it was 0. Wait, this number was 0, so it actually get rough. Yeah, so what are the active candidates now? So the active candidates are nothing but these force values are the active candidates. Let me Okay, these numbers are the active candidates. Let me now let's move forward. As these numbers are the active candidate to become an X, moving forward, here I get the, here I get moving forward, here I get the 0. Now according to my same approach, here I'm assuming just to get the 1 as an output, there need to be two values. One need to be high and other need to be low. But the number I have chosen at that particular position, at that number, the value is low. That means the number which I'm finding, among the remaining values at that position, within that number, it need to be high. But the moment I start finding that number, I come to know that there is no high value particularly at that position. Okay, if I come to know about if we reach to a position where there is no high value or there is no such value lies within the remaining values, what I'll do, I'll just overlook that value. Okay, I'm just ignore that particular position. Why I'll just do it? Just because the maximum number which I have assumed that I'm trying to find is actually an hypothetical number. This is not a real number, because after finding the value of x, when I perform the XOR operation between the this x and this selected value, definitely I will not get particularly this as an output. Definitely my actual maximum XOR value will be nothing. Okay, will not be nothing, actually will be something else. Okay, the maximum XOR between this x and this selected value will be something else, and I have hypothetically imagined that my value, that is maximum value, is this. Now moving forward, okay, so the moment I come to know that within the selected values there is no such value present which I'm finding, what I'll do, I'll just overlook at that value and I'll just ignore that position. So here I'm assuming that as there is no such one present, so what I'll do, I'll just add the 0 here. Okay, and overlook this value. Now moving forward, here the value is 1. Like within the hypothetical, like I am trying to find the maximum number, and for the maximum number at that particular position, the 1 need to be present, and the number that I have selected, and within that number the 1 is already present at that position. So that means the other input need to be present as 0. Means at this position I need to find the 0. I just want the 0. So when I try to start figure out whether at that position the 0 is present or not among all the remaining values, I just come to know that there is 0 present but on the 3 values, but one of the fourth active candidate is nothing, is have the 1 at that particular position. So what I'll do, I'll just remove that value from my active candidate position. So this value actually get removed out from the active candidate position. Okay, now what happened, the 3 values are actually left out, and here I'm adding the 1. Sorry, actually here I am adding the 0. Similarly, moving forward, just to get the maximum value here, I just want the 1 in my final output. But the number I have selected, within that number at that particular position, the 0 is present. So what I want in my number x at that particular position, I just want 1 in my that number. So what I'll do, I just try to find out whether at that particular position 1 is present or not. And the moment when I start searching, I just come to know there is actually only a single value within all these values, that is the remaining value, in which 1 is present at that particular position. So what I'll do, I'll just select that value and discard the other values. So both of the 2 remaining values will get out of my out as a active candidate from this active candidate position, and the number which is 10010 will become my maximum value, maximum value among all the values. Now what was my faith? Now let's try to figure out how this approach helps me to get the answer and less time complexity. Okay, so earlier what I was doing, earlier I was finding the other pair. Obviously, here also I'm just trying to find out the other pair, but on a reverse approach. What is my reverse approach is that I'm assuming that definitely I try to find out the maximum maximum XOR value. Now the moment I select any of the value from the provided value, that is the moment I select any of the value, just here I have selected this value. Okay, what I'll do, I'll try to find out the maximum XOR value, and the maximum XOR value is nothing but the 5 bit that is the 5 times 1. Okay, obviously the 5-bit maximum number is 5 times 1. So I have I have hypothetically assumed that this is the maximum number, and now what I'm trying to do is that I'm just trying to find the x, so that when I perform the XOR between that particular x and that the randomly, not the randomly, that selected value, I'll just get the maximum XOR value. And while finding the value of x, there are some cases which I encountered. What was this case? Uh, the case was, there may be a cases, means there will be a time when I don't get the actual value which will be present among the remaining values. Okay, means when just to get the maximum value here, I just want 1, but in my all the remaining values, there is no such value, which is present, in which at that particular position 1 is present. So what I'll do, I'll just ignore those positions. Why I just do this? I just do this because the maximum number which we have selected here is actually a hypothetical number. But when I perform the XOR between the actual selected between the actual number and the between the selected number and actual value of x, when I perform XOR between both of this value, my maximum value is actually something different from very different from this hypothetically selected value. Okay, so this is my reverse approach. This time I'm not going to find the maximum value. I'm assuming that this is my maximum value, and this maximum value is nothing but hypothetically assumed as a maximum value. That is nothing but 5 times, or means if I talk about the 4 byte, that is the 32 times 1. There's a maximum value of 4 byte number. This is a maximum value, and what I'm going to do, I'm just try to find out another value of a pair. When I perform the XOR between that value between those pairs, I'm just trying to get the same value which I have hypothetically assumed. Okay, so this is the approach which we are going to use here. Now what I'm going to do, I'm going to explain you by a try concept. Means right now what we are going to do is that we are just going to we just try to understand this whole concept by using a try. Okay, now I will create a try of these values and try to understand it how our code or how our solution will work on the try. Till now what we have discussed is the approach, and now what we are going to do is that a dry run. Okay, like how our code or how our approach will actually work on a try. So let's try to understand it, and let me remove for that. Now here also my values will remain same. That will be nothing but 0 0 0 1 0, and the another value will be nothing but 0 1 0 0. The third value is this, and 0 0 1 0 0 1 0 0, and 1 1 2 3 4, and 0 0 1 0 1. These are the values. Now let me create a try for these values. Now while creating a try, what will be the base means the initial value of the try? Like we are dealing with a binary data, and the binary data have two active values, that is either is the 0 and either is the 1. So here also we'll take the two branches of the try. That is we are going to create a binary try. That is nothing. Here we'll take the 0, here we take the 1. Now let's try to plot these values, all these values, by using this try. The moment we get this value, what we are going to do, we just try to create a try of that value. Here we get the 0. Okay, we reach to this side, and one more 0, one more 0. Now we get 1 and one more 0. Okay, we have created this try. Moving forward, here also we get the 0, but the second value is nothing but 1. So let's move forward. After 1 there is 0, there is 0, and there is 0. 3 zeros. Moving forward, here is the first, or the initial value is nothing but 1. There is single 1, and all the other remaining value is nothing but 0. So that is the 4 0. Let's try to plot this. Here at first we get this 1. After this 1 there is 0. So we move here, there is 0. We move here, there is 1, but there is no 1. That is the 0 is present here. So we need to create a branch of this. So we move here, and at last we plot this 0 here. Here again here there is 1 0. The moment we reach here, that is 0, the next element that at the next position, the 1 is present in our provided element, but within our try there is a 0. So what we'll do, we just create a new branch and put 1 here. Move forward, we put 0 here, 0 here, and we get 1 0 1 0 0. Similarly 1 present here. Okay, it was both of this number will become same, and it was, I'm putting here 1. Okay, now let's try to plot them again, and here it was 1 0 0 0. Now this will become 0. This number I have plotted this number. Now let's try to plot this number 0 0 1 0 and 1. This will become our try. Okay, this will become our try. So let me decrease its size. So we have created this try. Okay, now what we are going to do is that each time we select a single value from the provided values. Okay, and for that provided values we try to figure out the value of x. What will be the value of x? That is, the value of the x is nothing. So let's try to understand it. Okay, we have selected this value 0 0 1 0. Okay, it was the 5 bits, no? 0 0 1 0 0 0 0 1 0 0 0 0 1 0. Okay, so let me write a 0 at the beginning here. 0 0 1 0 0 0 0 0 1 0. The number is same. Okay, now let's try to understand the question. What we'll do right now is that we will select the x. We will find the x hypothetically. Hypothetically means we'll find the x with the maximum value of the 5-bit or the 4 or the 32-bit number. Okay, we find the max x. We'll find the value of x with the maximum value, with the maximum hypothetical value. And after finding that x, what we'll do, we just try to check that whether that x can be easily extracted out from this try or not. Okay, so let's try to understand. So we have selected this value. I am assuming that I'll perform an XOR between that value and the x, and as a result I get the maximum 5-bit number. Why I'm saying the 5-bit number? Because here I'm assuming that all the values are the 5-bit. If it is a 4-byte, then there are so many zeros lying at the present before that. Okay, now let's try to figure out what will be the value of x. As an output, we just want to get the 111. So as an input we just get nothing but 1 1 1 0 and 1. This can be our, okay, wait, let me remove this. Let me remove, yeah, 1 1 1 0 1. This can be one of our this can be the value of x. This is hypothetically calculated. Okay, it is not mandatory that that this value actually present on our input data set or not. There may be possibility that this value can be present or not, but what we are going to do, we are just trying to find out that is there any similar values actually present in our data, in our provided data set or not. Okay, so what we have done till now, for that value, for that selected value from the provided data, we have calculated a value of x with the concept that to get the maximum value, hypothetical maximum value, and the value which we get the x, now we are just trying to find a similar value on our try. Okay, so for that value, at first we get the 1. We reach to this 1. We check that whether any value starting with the 1 is present or not. When we get to know yes, there are so many values starting with the 1 is present, now we move forward. Okay, and we add this 1 in our answer. We move forward and we get the 1 again. Okay, now again we try to find out that whether a value at the 4th position. Why the 4th position? Because on the binary number the positions start from the left, from the right hand side, that is 0 1 2 3 4. Okay, so at the 4th position, whether is there any value that is present, having the value 1 is present or not. And here we come to know that no, there is no such value present whose 4th position have the value 1. The moment we come to know there is no such value present, what we'll do, we just add the next value that is present on our try, that is nothing but 0. So we just add this 0. We move forward, we reach to this 1. Again we ask the same question, whether is there any value present having this 1 on the try or not. Okay, at the 3rd position, the moment we ask this question, we come to know that yes, we have already explored this position, we get this 1. So we add this 1 in our final answer. Moving forward, checking for this condition, checking for this position, actually we here we need to search for the 0, and here we come to know that yes, 0 is present on our try. So we add it into our result. Similarly, for this one, we ask the same question, and the moment we ask this question, we come to know that one is not present on our try. But on the try, we can't backtrack just because we are finding the similar type of value. Actually, we are just trying to find out whether is there any similar type of value is present on our remaining values or not. Our goal is not to find the exactly same value, but our goal is to find the similar type of value. And the moment we ask for this zeroth index position, we just come to know that yes, there is one more value, that is having the value 0 is present. Okay, so we now we can say that the value which we have find it out till now, which we have find it out, and the final result, that is the answer, is nothing but a value of a pair whose XOR can be is the maximum XOR among all the other remaining value. This is not the only value. Okay, we now we perform this operation for this, for all the other remaining values. Okay, till now we have searched out for this value. Now we perform the same for this for this result also. Then we get something else. Okay, now we then we get something other pair, we calculate the XOR, we store it somewhere else, and at last we get how many XOR pairs we get. 1 2 3 4 5 6 7. At last we get the 7 XOR pairs, and from those 7 XOR pairs, what we need to do is that we just need to find out the maximum XOR. Okay, I hope you get out what I'm trying to trying to say. What I'm trying to say, like, at first I have find it out the pair of the first pair. Now we are going to we are going to find the second pair including this value. After that, we are going to find the third pair including this value. Then we find this fourth pair including this fourth value. Then fifth pair including fifth value, sixth pair including sixth value, seventh pair including the seventh value. And the moment we get all the seven XOR values, we'll find the maximum. We find the XOR among all those 7 values. Okay. So one more thing which I want to say is that I'm not going to explain the deep concept of the bit manipulation, because I'm assuming that right now we are on the level 2 and you have already completed your bit manipulations series. Okay, so, and you have already solved the question on that, so I'm assuming that you already know how can we easily extract that a particular bit position. Okay, how can we extract at that position value from this particular number, and how we update that particular value at that particular position. Okay, definitely we use the mask when we perform our operation with that mask, we update that value and we perform, and with that mask we get that particular position value. I'm not going to explain all this thing just because explaining the bit manipulation, the concept of this question and the code of this question is too lengthy. Okay, and even I'm assuming that you already know all these things. So I hope till now you get the concept of this question. Now what we are going to do, we just move on to the Pepcoding portal and write the code of it. Okay, so this is the Pepcoding portal, and now what we are going to do is that we are going to write the code here, and we just need to complete this find maximum XOR functions. Okay, so first thing is that we are going to write the abstract code. Means we are just going to assume that the function which we will use here is our who are actually already created up, and at the last when we complete the code of this function, we will try to create that function. Okay, so at first what we'll do, we just create the object of the try class. Try equals to new try, and I'm assuming that this class is already been created up. For int, now going to iterate over this provided vector, that is in nums vector. For int val nums, sorry, for int val nums, I'm going to call the try dot insert function. Insert with the val as a parameter. Now what this insert function actually does, it will create a try with a parameter val. Okay, whatever the value I pass, it just add it up into our try. Now again I'll create a max as a variable, max a variable. What this max variable does, it will store the max variable actually does, it will store my maximum XOR value among all the nums values. Okay, it will store the maximum value. Now moving forward, int val nums, again going to iterate over the provided vector. Now I'm going to write some code. Okay, after writing that code, I will explain you that what this code is actually doing. Okay, So for int find equals to integer dot max value and XOR with a val. Similarly, int res equals to try dot query, try dot query find, now int, okay, max equals to math dot max of max comma val and res. So let's try to understand. Okay, the last thing is that at last we just need to return the max value. So yeah, try to understand it. Okay, so what here we are, I have created the object of the try class. I am iterating over the provided nums and I'm passing, I'm assuming that insert function is already created up and it is working fine, and it works in creating up a try. It is at first, obviously, as we are going to solve this question on the basis of the try, then definitely we need to create it. So this insert function is working on creating up a try. Now this is the main code. At first we are calculating integer.max value, the XOR between integer.max value and the val. The first thing is A XOR B. We get the C. We already know it. But what if I write B XOR C? What will be the value of it? It will be nothing but A. Means I can write it like this: B XOR C, and we get the A. And the line that I'm writing here, that the integer dot max value, that is the I'm going to do the XOR of the maximum value, okay, the maximum value and the value which I have taken right now, and I'm performing the XOR between them. And what I'm getting is that I'm getting the value of X. Okay, this is the line which is working like that. Moving forward, that is the res equals to try dot query find. Okay, now according to our concept, the value which I get into the find is not actually the required value, because this value can be anything. Okay, I can say this is a hypothetical value. Okay, now but we need to select a value of a pair from the values which I'm provided within the vector. So what I'm going to do is that I'm going to pass this find value into the query, and what will be my feed from this query function is that it will trade over the try, and it will try to find the most similar value among the all the values of the try. Okay, among all the values of the nums vector, it will find the most similar value, and the value which I get at the last, which is most similar, I get it into the res, that is res variable. Okay, and the last thing, that is finding the finding the maximum, value between the XOR of both the A and B value and the maximum of the XOR of the previous maximum, XOR. Okay, so we have completed our find maximum XOR function. Now let's complete the code of the class. So public static class try. Okay, now I'm going to write the code of the try class. Similarly, here again I'm going to create one more class, that is public class node. Why I'm going to create it, let's try to understand. Because on the try there are only two values, that either I'll get the 0 or I get the 1. As we are getting only two values, so I can say that my try is actually looking like the binary tree. As it is going to look like the binary tree, I'm going to treat it like a binary tree. That's why I'm going to create it with the left children and the right children. That is, I'm going to assume that it will have only two children. So I'll write node.left and node star right. Okay, within the Java we don't use the star, sorry. Right. Okay, moving forward, I'm going to create the reference of that variable. That is, I'm going to create the object of this class and going to update it, initialize it. Now within the constructor of this try class, within this I just, okay, wait, node root, and within here root equals to new node. Yeah, till here our code is completed. Now what I'm going to do is that I'm going to write the code of the create function. So public void insert, void insert, and it will take some value, that is the val. Here also at first I'm going to write the code, and at last we try to analyze what this code is actually doing. So let me write some code. That is int index equals to 30 bit index 30, and node current will be root. Now while bit index is greater than equals to 0, what I'll do, at first I need to create the mask, and mask will be nothing but equals to 1 bit index. Okay, moving forward, let me get the bit at that particular position. Okay, so it will be nothing but mask, and well, if this value is actually greater than 0, is greater than 0, I'll I will put the value of 1, otherwise I'll put here 0. I'll check if bit value is 0. If bit value is 0, then I will perform some task. Otherwise I'll perform some other task. And after this else, each time I just need to decrement the value of bit index by 1. Okay, so bit index by 1, and I'm not returning anything from here. Okay, so that's all the code of this function. Soon we will now the only thing is writing the code within this if and else. So let me write it here, then we try to understand it. Current dot left, if it is null, then what I'll do, I'll just create a node. Current dot left equals to new node on that position, otherwise else, not the else actually, otherwise I'll just update the left pointer, current dot left. I'll move it towards the left side. Similarly here also I'll perform the same type of thing. If current dot right, if it is null, then I'll update current dot, create a new node on that side and move toward the right hand, otherwise I move toward the right hand side. So this is the code of the insert function. Let's try to understand some points. Okay, so the first thing is, great, I am creating a variable bit index and iterating and initializing it towards with the 30. Okay, so why I'm doing this? The first thing is that I'm assuming that the index is of 4 int integer here is of 4 byte. For the 4 byte I'm getting the 32 bits, and one of the bit, that is MSB, most significant bit, is nothing but more MSB bit is the we can see the sign bit. Okay, and that sign bit we can't means it is of useless. And after this 31 there are 30 bits which is left from 0 to 30, which is actually of useful for us. Now what we need, and for that maximum value of the 30, I'm just going to place 1 for that, and it is obvious. Okay, the 30-bit maximum value is nothing but 30 times 1. Now moving forward, I'm creating the reference of that root try, and here I'm creating a mask. Why I'm creating a mask, let's try to understand it. Okay, each time I will means according to my concept, I'm going to check on my try at each and every for each and every bit actually. So that means just to check at any particular bit, I need to extract out that bit. And if you have completed the video or the tutorial of the bit manipulation concept, then you definitely know that what this marks actually does. This marks helps us to get the portion value at that particular. This mark actually helped me to get the value at that particular position. Okay, so here I'm extracting that bit of that particular position. I'm checking whether that bit is equals to the 0, or bit is means a non-zero, that is it is 1. If it is 0, I'm going to place it to the left hand side, and if it is 1, I'm going to place it to the right hand side. So, and each time I'm going to decrement the value of, okay, bit index. So this is the code of the insert function. Now let's going to write the code of the query function. Okay, so here also at first I'm going to write the code of the query function, then we try to understand that how this query function is actually working. So int public int query and int find, public int query int find. At first int bit index, its value will be nothing but 30. Similarly, node current will be root, node current will be root, and int answer, the variable which stores my final answer. Now while bit index is greater than equals to 0, here also I'm going to write the same type of thing. At first, creating the mask equals to 1 bit index. Similarly, in accessing the bit at a particular position, so to do it, find and mask. Okay, if it is equals to 0, sorry, if it is greater than 0, I need to write the 1, otherwise I need to write the 0. Now if bit equals to 0, if bit is a 0 at that position, what I'll do, I'll check. Okay, wait, let me write here else I'll perform some task. What I'll do here, I will check if current dot left, actually current dot left is not equals to null. If its left is not equals to null, what I'll do, I'll move towards the left hand side. Current equals to current dot left, current dot left, because I know that on the left hand side there is a 0 and it is easily added to my answer. Otherwise, what I'll do, I just move toward the right hand side. Current equals to current dot right, and I need to update my answer or equals to mask. Okay, similarly this type the same type of work I'm going to do in the right hand side, that is in the else part. So let me copy and paste it. If current dot right is not equals to null, I'll just need to move toward the right, and before moving toward the right, I just need to update the answer. Okay, after moving toward the right, I just need to update the answer or equals to mask. But here in the else part, I just need to move toward the left and no need to update the mask. So after each else, I need to decrement the bit index. Okay, and at last I just need to return something. What is it? It is nothing but our final answer, return answer. So that's all the code. Let's try to run. Oh yeah, before running it, let me try to explain it. Let me explain this code to you. So at first, you already know why I have written here bit index and initialize it with the 30. You already know it. Node current, I'm creating the reference to that try. Okay, int answer equals to 0, that variable which stores my final answer. Bit index is greater than, okay, at first I am accessing that creating a node of that particular bit index, and within the bit I am accessing that particular position, that what is the value stored at that particular position. I'm checking whether that position is 0 or not. If it is 0, I'm checking whether its root is null or not. If it is not null, I need to move towards the left, and if it is not null, means I need to add the 1. Okay, here I'm adding the 1. I am updating the value of answer. In the else part, I am moving towards the right and updating the, and in the current dot right, we just check here also we just check if it is not null, means we need to add the 1 into our answer, and otherwise we need to move towards the left, and here each time I need to decrement my bit index value. So that's all for the code. Let's try to run it. Okay, so let me try to run it, and if we encounter any of the error, we try to solve it. Yeah, it is accepted for all the tests. Let's try to run it for all the test cases. Okay, so most probably it will work for all the test cases. Yeah, it is working. So that's all for this video. I hope you get the intuition of this question, you get the concept of this question. So if you like the video of this question, if you like the video, don't forget to hit the like button. Please subscribe to our YouTube channel, and let's meet in the next video.